Okay, this is problem one of the energy density problems. Now that you've read all the notes and done all the prior information, um, on your problem it says a power processing plant has an output power of 1,000 megawatts and runs at an efficiency of 36%. It uses wood with a specific energy of 16 megajoules per kilogram. So your goal in this one is to determine the rate of consumption of the wood. And so your two equations that you're going to be using for this is going to be your output equals your input times efficiency. You all know my handwriting is awful, so get over it. And then your second equation that you're going to be using is specific energy is equal to your input over your rate consumed, or your mass required. So we're just going to do mass consumed for that one. Okay, so you start out with 1,000 megawatts, and start out with 1,000 megawatts, and at you're running at 36% efficiency. So to find your consumed value, you're going to need your input value. So you're going to use this equation first to find your input. So if we rearrange this, it's going to be out over efficiency equals in. So that's 1,000 over 0.36, because it's efficiency percentage, and you're going to give us 2,777 megawatts for the input. Now you're trying to find this, so we're going to have to rearrange this one as well. So that's going to be your input divided by your specific equals your consume. Alright, so that's going to give us 2,777 megawatts over 16 megajoules per what is it, kilogram? So from there, that's going to give us 173.6 as our final answer. And now for units, megawatt, watt, if you remember your component units, is going to be kilograms and second to the -3. And then we have megajoules underneath. And so that is going to be m squared kg and s to the -3. Okay, so not -3, that's supposed to be a 2. So those both cancel out. You have your m squares cancel out, and your kilograms cancel out. So that leaves us with a nice s to the -1, which is going to be our unit for this. So your final answer will be 173.6 kilograms per second. And that is the simplest problem that we're going to be doing. And so that's pretty much just the baseline of how you do them all.